Okay, this is the final video on percentages at National 5 level, and this particular type is percentages year on year. Now there's a nice wee formula that we can use to work these things out, and I'll show you that. And before I actually just write down the formula, I'm going to show you where it comes from because it's quite easy to work it out. And to explain the formula, I'm going to use money in the bank, and it's in the bank for say maybe 3 years. How much money would I have if I have a particular interest rate? We'll say 10%, make the numbers easy. And rather than working out separately every year, which I'll do at the beginning to show you the formula, we can then just use the formula and plug in numbers and get answers to it. Okay, so let's imagine I have some money in the bank and we'll call it X naught, and that's at the beginning of the year. I have that amount in the bank, and let's say I get a 10% interest every year, so 10% interest each year. How much will I have after 3 years? Well, this is how we go about it. Well, after the first year, we'll call that X1, so that's after 1 year, I would have in the bank X naught plus 10% of what I originally had in the bank. So let's do 10%, so that's 10 over 100. Now I'm not going to work that out, I'm just going to leave it like that, X naught. Now we can simplify that a wee bit by taking out a common factor, and that will give us 1 plus 10 over 100. And deliberately not simplifying that just now. Okay, well, second year. In the second year, I will have X1, because that's what I had at the end of the first year. So after the second year, I have that plus 10% of that again. So there's another 10%, and it's X1 this time, because we had that at the beginning of the year now. And again, we can do the same idea. We can take out a common factor at X1, which gives me 1 plus 10 over 100. So that's at times. Okay, now we can simplify that a wee bit more. This value X1, well, we know it's that value there, so that's going to be X naught 1 plus 10 over 100. And we've got another one of them. So you might have to take a wee bit of time to think about how I got that. So after the second year, it's X1 plus another 10% of X1, which equals X1 times this. We'll take out a common factor of X1. But X1 is equal to that up there, that line there. So we can put that in. Now we've got two of these and we're multiplying them together. So that gives me X naught 1 plus 10 over 100 to power 2. And look at that power 2, that's the time period, that's after 2 years. We'll do it once more, so we'll say after 3 years x to the 3. Well, that's going to be whatever we had after 2 years plus another 10%, because it's 10%, it's the same percentage each year, and this is why this formula is going to work. Take out a common factor, X2, I have a bracket of 1 plus 10 over 100. But we know X2 is equal to that thing there. So that's going to give me X naught, this bit here, 1 plus 10 over 100 squared, and another one of these. Again, take a wee bit of time to see where this comes from. X2 from this line here, X2 is equal to X naught times that value in the bracket squared. So that's why we can put that in there for X2. And that simplifies again to X naught 1 plus 10 over 100 to power 3. 3 being how many years? So that leads to this formula here, V equals the initial value, we call it I, initial x naught was our initial value in this particular question. That's the initial value, bracket 1. Now I'm going to put plus or minus here because it was an interest, the money was increasing each year. But if it was decreasing, if it was a decreasing percentage, then we put a minus here rather than a plus. And then it's a percentage, whatever we're talking about. In this case, we're talking about 10% over 100, all to the power n, which is a time period. So I think I'll just note this for you. V equals value, I equals initial value, the value you're starting with, plus or minus, excuse me, that means it's increasing if it's a positive, or decreasing. So we can use a plus or a minus depending on the question. And percentage obviously is the percentage in the question. And n is time period. Now the time period in this case above was each year, but it could be minutes, weeks, months, seconds, could be any time period. So don't always think about it has to be a year, it can be any time period. And that's what each of these symbols mean in the equation. Okay, this bit in the bracket, this bit in here, you'll find in some textbooks, it's called the multiplier. Some teachers like just to work that out first, and it's called the multiplier. So you need to be aware of that in case you're reading some books or some textbooks and they talk about multiplier. It's a bit in the brackets. Okay, so that's me derived it. You don't have to derive that for National 5, you just have to be able to work with it. And being able to remember that formula, again, you're not giving it an exam, you have to remember it. And if you remember it, it makes these questions very, very easy. So I'm going to show you two questions. One an increasing value, one a decreasing value, and how you work it out. And I'm only doing two questions because every question is done the same way. So once you know how to do one, you can do any one. So I've just picked a couple of past paper questions. I'll split my page. And the first one, I'm not going to write everything in the question, but I've got a house. I've got a house that's valued at £134,750. And we're told it's increasing, so increasing at a rate of 3.15% per annum. Question is, how much is it worth? How much is it worth after 3 years? And we're asked to give to 4 significant figures. Okay, I'll just put this in brackets, 4 significant figures. Okay, so that's the question, roughly the question in the exam. There's a wee bit more to it in terms of the words, but that's the key bits of information that we need. So we have to work out the house price just now is that. It increases by this amount each year. How much is it worth after 3 years? Remember, per annum means per year. Okay, per annum, per year. Well, write down the formula. Now, our formula plus or minus, but it's going to be a plus because it's going up in value. It's increasing, I'll just underline that. It's increasing, so it's plus the percentage over 100, all to the power, well, the time period is 3 years, so it's the power 3. Okay, so let's put our stuff in, but our initial value, is that amount, so it's going to be 134,750. 1 plus the percentage is 3.15 all over 100, all to the power 3. So you can see that rather than doing it every year, one at a time, this wee formula's nice and straightforward. All we have to worry about is that we don't make any typing errors or when we're writing down the formula. Okay, so we take all that value and the numbers and we just plug it in our calculator, and the calculator will throw up the answer for us. Okay, so according to my calculations, I've got this here. It's £147,889 and 20 pence. Now, that's an accurate figure to the nearest pence, but we're told the 4 significant figures, so we have to round that to 4 significant figures. Well, here's the first significant figure, that's 1. Second is 4. Third significant figure is 7. And the fourth significant, well, this is the fourth significant figure here. Now, the one beside it is 8, so that changes to a 9, and everything else goes to 0. Okay, so to 4 significant figures, that's our answer. Remember, we wouldn't have any decimals here. 4 significant figures means 4 numbers, the rest go to 0. Okay, so that's one when we're using the formula is increasing. Let's look at one that's decreasing, and I'm going to pick something that's not money and it's not year on year. So let's look at this question. It's all to do with temperature in a greenhouse. So the temperature in a greenhouse is dropping. So the temperature in this greenhouse is dropping at a rate of 4% per hour. Okay, so we've got a temperature in the greenhouse and it's dropping at a rate of 4% per hour. At 8 PM, the temperature was 28 degrees Celsius. Question: what is the temperature at 11 PM? Okay, so that's our question. What was the temperature at 11 PM? Well, write down my formula. V equals I bracket 1. Now this time, because it's dropping, that's decreasing, dropping, it's a minus this time. Percentage over 100, all to the power n, and n in this case, well, we'll work that out a wee minute. We'll just put n in there and we'll work it out. So our initial value is 28 degrees. 1 minus, the percentage is 4%, so it's 4 over 100. Right, the time period, well, at 8 o'clock it was 28 degrees. We want to know 11, and it's losing 4% per hour, So 8 to 9 is 1 hour, 10 is 2 hours, and 11 is 3 hours, so it's the power 3. And again, just plug in my numbers and see what happens this time. Now, you should be aware that the temperature is going to be lower because it's decreasing. So just in case, use a wee bit of common sense in case you make a wee mistake as you're plugging in the numbers. We're expecting a smaller value. And the smaller value, there we go, according to my calculations, 24.8 degrees Celsius. Okay, and that's that question, and that's how you do year on year percentage question. Say year on year, because it was developed or mostly used in the banks for calculating interest. That's why it's called normally year on year, but it's not year on year. It's a time period. As in this one, it was hours. Could be seconds, minutes, whatever, weeks, months. Okay, so that's all you need to know, and that's us. This is the third video on percentages, and that's the last video. So that's everything you need to know about percentages. If you're looking for the past paper questions on any of the percentage types that we've done just now, mathsrevision.com, National 5, go down to the bottom, pick in the star, and you have 20 years of past papers with these type of questions on it. Okay, so that's us.